Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So we have 2 drops of water, 2 drops of rain. This falls and time t, which is not known and they want us to find out after it already covered some distance, the second drop falls. So both drops are coming from the same point and they are traveling for some time. So for example, this first drop covers t is this time, and then there is another time t capital. So in total it travels time t plus t. This is the total time of the first drop. The second drop, it travels only time t capital because it's sitting, it just comes with delay, and so it comes somewhere here and it comes somewhere here and it travels time t, the same time t that this goes from here to here. So t from here to here and t from here to here for the first one and t for this, and then this distance is d. So let's write the distances. We know the times and distances. Obviously we want to tell that this distance total is equal this distance plus this distance. So the first drop goes, v0t is gone, so what's left? Pause. Correct. Only g, and the total time, which is t capital plus t lowercase squared over 2. This would be this distance d1, right? And this would be distance d2. That's the second drop. It's absolutely the same situation, only it goes this time. T capital. So d1 and d2, and just looking on this we can say that d2 plus d equals d1. So we say d1 equals d2 plus d. What is unknown? Physics is done. What is unknown? d1, d2, right? And t lower case, because t uppercase is known and d is known. Those two are known, so those are unknown. So let's get rid of d1 and d2, put d1 here, put d2 here, and we will immediately receive g t plus t squared over 2. This is d1 and it is here, equal d2. And I have to write it exactly as it is, gt squared. And I remove this because it's on the way. Gt squared over 2, right? It's d2 and plus d. Let's get rid of 2. Multiply everything by 2 and let's open the brackets here. So we have g, inside the brackets, a plus b squared equal a squared plus b squared plus 2ab. So it would be t squared plus b squared, it would be, because this is a and this is b, and plus 2t capital over t lowercase, right? Equals gt squared and plus 2d. And so, by the way, when I get rid of d1, d2, I got only one equation with one unknown. And this unknown is t lowercase, because t uppercase is given to us. It's 2 seconds. 2 seconds, the second drop is traveling. And it's given to us, so we have this. So let's open brackets. So we have gt squared plus gt squared plus 2gt t lowercase equal gt squared plus 2d. And of course we can get rid of this gt squared, and gt squared is gone. And what we have, t is unknown and t is squared, so it's quadratic equation. So let's put this quadratic equation in one side. Gt squared plus 2 gt t minus 2d equals 0. And let's put some numbers here. Instead of g we put 10 t squared plus 2 multiplied by 10. T capital is given to us, it is 2. T lowercase minus 2 multiplied 25 equals 0. So we have 10 t squared plus 40t minus 50 equals 0. What can we factor out? Pause. Of course we can factor out 10, and we will have plus 4t minus 5 equals 0, and we have t squared plus 4t minus 5 equals 0. And of course t12 equals quadratic equation. You have to be fluent with that. I probably will make a playlist about algebra, about all of this. But for now, t12 equals minus 4 plus minus square root. 4 squared would be 16. Minus over this minus would be plus 4 multiplied by 5 and divided over 2 equals minus 4, and of course I take only positive solution here. 16 plus 20 would be square root of 36. Square root of 36 divided over 2 would be minus 4 plus 6 over 2 equal 1. Right? So 1 second is the distance between those two drops. 1 second, and let's check ourselves what's going on. Let's draw this now, we know, and let's find out what happens with those distances. So, if this would be 1 second from here to here, then this distance would be gt squared over 2. It would be 10 over 2 multiplied by 1, it would be 5. So this distance would be 5 meters. It would be 5. And this where would be the first drop when the second drop starts. If this is 1 second and it goes for 2 seconds, then it gains, the whole time would be 3 seconds. And the full distance this body travels to here would be g multiplied by 3 squared over 2. It would be 10 over 2 multiplied by 9, 10 over 2, 5, 5 by 9, 45. So it would be 9 times more, it would be somewhere here. So this would be the distance, 45 meters. And this would be 45 meters where the first drop will end up when we finish our observation. Okay, now let's take a look what happens with the second drop. The second drop starts when the first drop is already here, and it covers the distance gt squared over 2, and t is 2. It's given to us. This is the time after we will observe this distance 25. So it would be 10 over 2 multiplied by 4. It would be 5 multiplied by 4. It would be 20. So when this would be here, the second drop will pass the distance of 20. And so what we have, the distance between them, this is 45 and this is 20, and so this distance is 25, so everything matches and we solved it correctly. There would be part 2 for this problem because I can show it a little bit different solution and maybe it would be easier for you. So I will remove some, but not all. I remove this and I will record the second solution shortly. Meantime, subscribe, bell, like, question, problem, and I see you soon. Thank you.